All right, so on page 195, problem 45, we have two spherical balls are placed so that their centers are 2.6 meters apart. The force between them is 2.75 times 10 to the negative 12 newtons. What is the mass of each ball if one ball is twice the mass of the other? So here's what we get given. Let's draw a picture of it. So here's one of them, and we'll give it a mass of m. Here's another one. We'll draw it a little bit bigger, and it has a mass of 2m. So there's the masses. So this tells, oh, okay, this is twice the mass of this other one. We've got a force of gravity pulling them together, and it's, of course, very tiny because gravity is weak. You know, these aren't very big, so the gravity is going to be 2.75 times 10 to the negative 12 newtons. And, of course, we're given how far apart they are. The centers are 2.6 meters. And, of course, what variable is that? We'll call that r. Okay. And so we're trying to find m. Well, m and then the other one, we're trying to find 2m. But if we find one mass, we've found the other. Okay, so let's solve this. Well, this is a gravitational force. So we're going to say the force of gravity is equal to g times the mass of one times the mass of the other over r squared. That's our basic equation. Well, we can rewrite this saying g and m1 is just m. m2 is 2m over r squared, okay, equals the force of gravity. And now we can solve for m, because that's what we want to find. We want to find m. So you take your equation and solve it for m. Notice that we know the force of gravity. That's given. We know r and we know g, so that's the only variable that's left. Yes?
I just want to have a quick question. Is there a difference between a little r and big r? Like,
yes.
What's
yeah. Usually if it's a capital R, that's the radius of a planet or something like that.
And the one that's just like...
Little r is the distance, is this distance between the center of one object and the center of the other. And little r quite often represents, if we're talking about circular orbits, the radius of the orbit. Which is good. Now, so now what I'm going to do is I'm going to rewrite this. This is g. I'm going to take the 2 out here. 2g m squared over r squared equals the force of gravity. Now I'm going to solve for m. So if I say m equals, well, I got the force of gravity here multiplied by the radius squared, or r squared, divided by 2, divided by g, and then what do you have to do to get m? Because this is m squared, isn't it? Let's take the square root. And then you have to hope that your calculator doesn't fail you. Now we're ready, because now we're ready to plug in numbers. 2.75 times 10 to the negative 12 newtons times 2.6 meters squared divided by 2 and divided by g. 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. Now you have to have good calculator skills. Yes?
How do you get from the g m2m over r squared to...
Okay, it's just... I'll show you later, but it's just algebra. I just took the m right here. I want to solve for this. So this stuff equals the force of gravity. So multiply both sides by r squared, divide both sides by 2g, and then take the square root. And now I'm just substituting in the values for these things.
I know you circled the big one.
How do I know it's m squared? Well, because...
Yeah, from there to there.
From here to here? Okay, look, we said the force of gravity is G times the mass of one object times the mass of the other object. Well, the mass of one object is m. The mass of the other object is 2 times m. Then I combine these together. M, what is m times m? M squared. And then I just put the 2 out in front of the g. I just kind of rearranged this right here to get that. Okay? Then you plug all that in, and you should get, if your calculator skills are adequate, you get 0.37 or 365 maybe. I don't know. Huh? 3708. Okay. We'll just call it 0.37, round it off, kilograms. That's m, yeah, and then you just multiply that by 2. So 2m is, what is 0.74? Yeah, that makes sense. 0.74 kilograms. And so there are my answers. Yeah, there's multiple ways of doing the arithmetic. So, tell you what, if I'm going to make this worth 5 points. If you used Newton's law of gravity, that's worth a couple points. If you plugged in like the mass of this and it said this was 2m, so you got an m squared, and then you tried to do that and manipulate that, that's going to be worth 2 points, all of this part right in here. And then this correct answer is worth half a point, and this correct answer is worth half a point. So if you did all the work right, you set it up correctly, you should get 4 out of 5. Even if your calculator skills failed you, you'll get 4 out of 5. It's out of 5 points. I'll just make it worth 5. Yes.
On my final answer, I didn't put the unit.
Oh.
I didn't transfer the unit.
Take.
I did in my work.
If you always need to have units with your answer. So I'll just take half a point off total, not half a point per answer, but just half a point total. So you get 4.5 out of 6. 4.5 out of 5. Okay, so here's the whole thing. Let's take a look at it. And there you go. That is all.